All right, today we're talking about trapezoids and kites. A trapezoid is a quadrilateral where two of its bases are parallel, meaning they'll never cross. The other two, not so much. Because it is a quadrilateral and based off of our interior angle sum theorem that we learned earlier on in the section, a quadrilateral will always have 360 degrees as far as its interior angles add up to. Yeah, that's enough of that. So if we have what's called an isosceles trapezoid, and what that is again, the top and the bottom are still parallel, but the other two legs are the same size. That would, just like an isosceles triangle has two legs that are the same size, the isosceles trapezoid has two legs that are the same size. And in this situation, the base angles, two angles that are connected to the bottom of the legs, will be the same size, as well as the base angles from the top. The two angles that are connected to the tops of the congruent legs will be the same. So that is the first thing you want to know for solving problems today. Next, as long as we have one pair of congruent angles, base angles, that guarantees that the other pair of base angles is also congruent, because that proves that it is an isosceles trapezoid. And finally, we can look at the diagonals of a isosceles trapezoid. If a trapezoid is isosceles, then the diagonals are the same size. They are congruent. If trapezoid QRST is isosceles, then QS, which is this diagonal, is congruent to RT. Likewise, if you're not sure if it's a isosceles trapezoid, you can check, is RT the same size as QS? If RT and QS are congruent, then yes, you can go backwards and prove that you've got an isosceles trapezoid. So these are the fundamental ideas to proving that trapezoid is isosceles, and also just the properties of isosceles trapezoids in general. Next, let's talk about kites. Get there. All right, a kite is convex, meaning none of its vertices cave inward, but it is also a quadrilateral with exactly two distinct pairs of adjacent congruent sides. So unlike the parallelogram where the opposite sides are the same size, the consecutive or adjacent sides are the same size. So PQ and RQ would be the same size in a kite. PS and RS would be the same size in a kite. So not quite the same as a parallelogram. Also, you'll notice none of these lines are parallel. If I were to continue drawing these lines, they would eventually meet, like so. If I continue drawing PS and I can continue drawing QR, you see that they eventually meet. They are not parallel. So that's the other thing about kites. They don't have parallel sides, but the congruent sides are the ones that are next to each other, the ones that are adjacent to each other. Now, the next thing to know about kites, if a quadrilateral is a kite, like so, then its diagonals are perpendicular. Again, what perpendicular means is the way that they intersect or the way that they cross is at 90-degree angles. So for a kite, the diagonals will always be perpendicular. They will always form 90-degree angles. And the last thing to know about kites is if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. Again, this is different than a parallelogram. The two angles that are in between the two unique sides, so in this case J and L, are going to be the same size. K and M will not be the same size, but J and L will. So again, notice that JK and LK are the same length. I can tell because they have these single tick markers. The angle that is in between them, the included angle of JK and LK, is not the congruent one. It's the angle that is between the 1 tick mark and the 2 tick marks. That angle is the one that is equal to the other one that is in between 1 tick mark and 2 tick marks. So these are the different properties of kites and trapezoids. Now that we've talked about the properties, there's one more piece of a trapezoid that I feel is necessary to talk about, and that is called the midsegment. Get to the start of it. I'll go through examples in a different video. So, midsegments of trapezoids. The midsegment of a trapezoid is the segment that connects the midpoints of the legs of the trapezoid. So here's this leg. This is the exact middle of the left leg, just like this is the exact middle of the right leg. The line that connects the two of those, or the line segment that connects the two of those, is called the mid-segment because it connects the midpoints. Go figure, right? Now, here's the mathematical part. Here's what you've got to know that is different. The mid-segment of a trapezoid is parallel to each base. So this middle line is going to be parallel to the two bases, meaning you'll have 3 parallel lines once you draw your mid-segment. And also, its length is half of the sum of the lengths of the bases. Half the sum of the length of the bases. So what that translates to is this equation here. AF, I'll underline in red, and AF is this line right here. CD, I'll do in green, is right here. What it's saying is that I should add whatever this number is plus whatever this number on CD is, and then after I add them together, I should cut it in half, aka divide it by 2. And what that will do, if I add them and then divide them by 2, will give me this mid-segment's length. There will be questions asking about that, so it's important that you know how to do that. All right, I will make another video going over examples, but that is it for how to do this.